Hello everyone, welcome to Pace Digital. So today in this video, we are going to discuss regarding a very important chapter, that is binomial theorem. Right, you heard it right. So binomial theorem is a very essential chapter for your 11th and 12th syllabus. Along with that, JEE holds a very good weightage on this chapter, isn't it? So what do you think? Formula is what irritating you, right? So how to remember these formulae? How to get in touch with all the important formulae? And do you think that we have too many formulae in this chapter? No, just one formula from which you can get all the formulae, right? So all these formulae can be derived very easily through these small tricks, what we are going to help you with, right? So when you talk about binomial theorem, what exactly you mean by a binomial? Think about it. What exactly is a binomial? Binomial is nothing but a polynomial, you would say, which contains two terms, isn't it? So two terms in the sense some a plus b or some x plus y, right? When we're talking about binomial expansions, it is like x plus y whole square, a plus b whole cube, a plus b whole power 4, all these. So till date, we are very much familiar with what is a plus b whole square. Now come on, tell me, what is a plus b whole square? Yes, you're right, a square plus 2ab plus b square. Right, coming for a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube. Fine, everything is clear, right? Now coming for what is a plus b whole power 4. Yeah, there you're stuck, isn't it? So this is what very essential to learn. So all these also can be cracked very easily. Even you can do what is your a plus b whole to the power 10 very easily, a plus b whole to the power 20. Not only a plus b whole to the power 20, this topic can be extended to a plus b plus c also, considering your a plus b as a single term, b as another term. It's again the binomial expansion what we put there. Right. So very beautiful chapter if you understand the knack behind that. Clear? Right. Coming for what is a plus b whole to the power 1, we all know that is a plus b, isn't it? Now coming for what is a plus b whole square. So that is your a square plus 2ab plus b square. Now a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube, right? Now in the same way, can you guess what could be a plus b whole to the power 4? See, one thing we can guess. Observe the powers here. A power 3, a square b, ab square, b cube. What did you understand from here? So we started with a to the highest power there, 3. Later on, we kept on decreasing the powers of a and increasing the powers of b. Did you understand that? So the first term, do we have b? No. We just have a cube. That's it. Next, power of a automatically decreased by 1 and b started existence now, right? So now your a has got a power 2, b has got a power 1. Next, again, another step down for a, that is a, and now b again has increased to b square. Another step down for a, that is a to the power 0. It's almost nullified there, isn't it? Now coming for b is in topmost priority, that is b cube. Even if you observe a square also from there, a plus b whole square. So a square reduced to a to the power 1. B started its existence there. Next, again, a has nullified and b has also taken a highest power there, which is b square, right? Now, so obviously in this pattern, if I observe, I will definitely get, I will be starting with the a to the power 4. Obvious, fine. Next, it could be a to the power will be decreasing, 3, and b to the power 1. Next, again, a square, another step down, b to the power 2. So a is gradually decreasing and b is gradually increasing there. Got it? So next, a with b to the power 3, and now a will be taken to the power 0 there. So a to the power 0 is always 1 and b to the power 4 there. Understood that? Right. So now what about the constants? I don't know regarding the constants. So here we have included 2 here. Next, 1, 3, 3, 1. And I don't know regarding what are the constants that I need to take there for each and every term. For this, Pascal, a great mathematician, has given a triangle for us. So using this triangle, we can get the coefficients there very easily. And how is that done? See, 1 and 1. A plus b whole to the power 1 I'm talking about. Their coefficients are just 1 and 1. right? Next, observe, we have three terms. If it is power is 2, now observe the degree here. So if the degree is 1, 2 terms is what we have. Now, if the degree is 2, how many terms we have? We have 3 terms. Think about that one also. So we have 3 terms, 1, 2, 3, wherein a power is decreasing and b power is increasing, right? Now, observe here carefully. I'm starting with 1 here. Addition of these two, 1 plus 1 is 2. Again, another 1. Clear? Next, if I have 3 terms, what am I doing here? If I have power 3 in the sense it is, we have 4 terms there, 1, 2, 3, 4, 4 terms there. Now I'm taking 1, addition of 1 and 2 is 3, addition of 2 and 3 is 1, again with 1. So when you observe, your leftmost and rightmost extremities are 1. And what is the next term that we are getting? It's the addition of the next 2 terms there. Clear? Similar way. Now guess for what is 4. Now it's 1 here. Next, 1 plus 3, 4. 3 plus 3 is 6. 3 plus 1, 4. Another 1 there. Right? Now I'm going to include my coefficients. That is a power 4 plus 4a cube b plus 6a square b square plus 4ab cube and 1b power 4. Understood? Did you all understand? Right? So that's the way you write it. Come on, guys. Now let's go with when you have a power 5, a binomial with a power 5. I'll be starting with 1. Next, 1 plus 4, that is 5. 6 plus 4, that is 10. 10, 5, and again 1. Right. Now let us go with this. What is a plus b whole to the power 5? That is what? Yeah, I'll be starting with obviously a to the power 5, isn't it? A to the power 5. Next, slowly a power decreases and b power increases there, right? Now, what is the coefficient? 1 is already written, so hence we have a 5. 5a to the power 4 with b is existing now. Next, plus 10a cube b square. Decrease a, increase b. That's it. Next, plus 10 a square b cube. Next, plus 5 a b to the power 4 plus b to the power 5. Understood? So this is the way how you remember things. But when I ask you, what is a plus b whole to the power 10? What is a plus b whole to the power 10? Are we going to do this exercise, a plus b whole to the power 6, 7, 8, 9, 10? All this, don't you think it is very tedious? Even for this, we have a solution. That's the beauty of the chapter, right? So even for this, we are going to give you a solution for that. So what is a plus b whole to the power 10? We are going to discuss. What if it is a plus b whole to the power minus 3? I have done what is a plus b whole to the power 3. But what if it is a plus b whole to the power minus 3? That also gives you the solution here. Next, what if it is a plus b whole to the power minus 2 by 3? Even fractional power also resolves just like this, right? What if it is a plus b whole to the power 5 by 7? Even if it is rational power, that means even if it is negative rational number or a positive rational number, even if it is a negative integer or a positive integer, any binomial expression just sets down only with one formula, and that the beautiful formula is what we are going to discuss now. Nothing else is needed, just one formula, that's it. Understand the logic behind the expansions, what we have written here, right? So what is the logic behind the expansions? Think about this. When you have a power 2, either I am giving the whole power to a, that is one option I am doing, or I am distributing the power among a and b, that is another option I am doing, or I am giving the whole power 2 to b, right? Is this what I am doing? Is this the whole power 2 is distributed among the 3 terms there, right? Now, when you observe a plus b whole power 3, what did I do? Even here, the first step, what I did? I have given the complete power 3 to a, right? So complete power 3 is given to a, or I have given the power 2 to a and b as one power there. Clear? Power 1 for a or power 2 for b, or the whole complete power 3 for b only, right? So is it nothing but are we distributing the power to a and b terms given in that binomial expansion, right? And how are we going to distribute? Are we missing out anything? No, right. We are not at all missing out any chance. Either I am giving complete power to A or complete power to B, or distributing them very much equally without any partial nature, isn't it? So I have given 2 to A and 1 to B, 1 to A and 2 to B. Even observe A plus B whole to the power 4, given completely for 4. 4 as a power for A or 4 as a power for B. Later it has got decreased 3 to 1 and 2 and 2 and 1 and 3. Did I miss out any chance? Any other chance was missed out? No, right? So this distribution technique is what we are going to use in deriving our formula. And what is that? See, when I am selecting from some 10 terms, if I have some 10 terms, or if I have some 10 students, if I have to select some 2 students out of these 10 students, in how many ways I can do that? Let it be some roll number 1 to 10 are there. So how many ways I can select those 2 students? That is, either I can go with 1 and 2 roll number, or 1 and 3 roll number, or 1 and 5 roll number, or 2 and 6 roll number, 2 and 10 roll number, or 3 and 7 roll number. I have so many chances. All these chances will be coming into this case. Right. So how many ways, number of ways of selection will be coming under your permutations and combinations chapter. That means suppose if I'm selecting 2 terms out of 10 terms given, I write it like 10C2. And what is the way to expand this? It is nothing but 10 and 10 times 9 divided by 2 factorial. 10 you decrease it 2 times, 10, 9, and then divided by 2 factorial. If it is 7C3, out of the given 7 elements, you are selecting only 3 elements. What are they? It is nothing but 7. See, observe, 7 has to be decreased 3 times. From 7, 7, 6, 5 upon 3 factorial. 3 into 2 into 1. Clear? If I give you 5C2, which means I am selecting 2 only out of the given 5, which means it is 5 into 4, decreasing 5 2 times, 5 into 4 upon 2 factorial, that is 2 into 1. Clear? So this is the logic which I am going to apply to derive my formula there. Clear? Right, guys. So now x plus a whole to the power n. So if at all we go with the earlier logic, that is giving the entire power to n, or keep decreasing now. X to the power n minus 1, gradually decrease x, gradually increase a, right? So a, and next that is n, wait. X to the power n minus 2, one more decrease for x, another increase for a. Similarly, x to the power n minus 3, a to the power 3, so on. Keep writing. And another general term is what we will write. One general term in between is what we will write. That means some rth term, let it be. I don't know what is that term, some rth term. That will have how much? X to the power n minus r, a to the power r, so on till final step will be what? Finally, what do you end up with? X has not got any power there, and a to the power n will be there. Now coming for what are the coefficients there? Right. So earlier we were having like 1, 2, 1, all these coefficients is what we had, isn't it? So all these coefficients is what, how are we going to decide that? So that means, now observe clearly, the first one, NC naught, which means I am giving the complete entire my power to n only. I am not at all distributing. Right. So next it is NC1, next NC2, next NC3, next NCR, next here NCN, right? So just take the addition of all these. This is nothing but your binomial expansion. Now, this term in between whatever I have written, which term do you think? Is this rth term, or r plus 1th term, or r minus 1th term? Think about it. The first term has got NC naught. Second term, this is first term, this is second term, this is third term, isn't it? So when you go that way, when you have a 2, that is third term, one more than that. When you have 1 here, that is second term. When you have 0 here, that is first term. When you have 3 here, that is your fourth term. So when you have r here, it will be which term? That is r plus 1th term, represented like TR plus 1 is NCR x to the power n minus r into a to the power r, the most important terminology. So what is the rth term of the given expansion? They might ask you out of some 10 terms or 100 terms might be there. They might just ask you, tell me what is 50th term. How do we do that? When we know the r plus 1th term. They might ask you what is the coefficient of some a to the power 10. How are we going to do that? Using this. Clear? So this r plus 1th term, general term, which plays a very, very major role. Okay, so this is the general term of the binomial expansion. That is TR plus 1 is NCR x to the power n minus r and a to the power r. Is that clear? So make a note of this. And to tell you, what about NCR? What do you mean by how do we get NCR? So NCR, what is the formula behind that? So if at all we don't know, suppose if I just now discussed regarding that, isn't it? If it is 4C2, which is nothing but 4 times 3 by 2 times 1. So if it is NCR, I cannot keep writing all this. It is like n into n minus 1, so on till r times is what you have to decrease by r factorial. Rather than that, it is n factorial by n minus r factorial into r factorial is the formula behind writing the value of your NCR, right? So the first point what we have learned here is what is the general term of the binomial expansion. Now coming for the next thing. So we need few terminologies. The second one, that is binomial coefficient. So what is binomial coefficient? All these NC0, NC1, NC3, so on till NCN, whatever we have written, all these are our binomial coefficients. Clear? So binomial coefficient is just NC0 or NC1 or NC3. What is the binomial coefficient for the third term? Tell me. For the third term, what is the binomial coefficient? That is NC2. For the fourth term, NC3. If I ask you for 50th term, 50th term binomial coefficient will be NC, perfect, 49. Isn't it? Just one less than that you need to tell me. Clear? Understood that? Right, coming for the next thing. So the other part what we have to learn is, so one is general term, other is binomial coefficient, and the other one is just the coefficient. It's like the other one is the coefficient of x power values there. So it is nothing but the coefficient of x to the power r. So what will be the coefficient of x to the power r? It is your NCR a power r completely. Other than this x to the power n minus r, you just tell me NCR a to the power r. That's it. So binomial coefficient is just NC, not NC1, NCN. Whereas coefficient of x to the power something in the sense everything else will be coming along with the constant what you have there. Is that clear? So these are the three things which are very, very essential. One is r plus 1th term, the general term. The other one is what is binomial coefficient. This binomial coefficient, as we move on, you need not write NC0, NC1, NC3. You can just mention C0, C1, C2, C3 enough, which obviously specifies your NC1, NC2, NC3 only. Right. The third one is coefficient of x to the power r. Understood? Coming for the number of terms in x plus a whole to the power n. So number of terms. So make a point, most important thing, yes. So in x plus a whole to the power n, how many terms do we have? So in a plus b whole square, how many do we have? A plus b whole square, we have 3 terms. A plus b whole to the power 3, we have, perfect, 4 terms. A plus b whole to the power 4, we have 5 terms. So similarly, now can you guess me how many terms are there in x plus a whole to the power n? Obviously, n plus 1 terms, isn't it? Good job. Right, so we have n plus 1 terms. Now tell me, if at all we have even number of values, let it be even number of values. Out of 4 even value, 4 is even number, isn't it? How many middle terms do you get? 2 middle terms. That is your second and the third term, isn't it? So if you have odd number of values, right? So you'll have only 1 middle term. So remember this point, even and odd. How many middle terms we get? If at all number of values, what we are considering is even, you get 2 middle terms. And number of values is odd, we get 1 middle term. That means if I have, see, 1, 2, 3, 4, 5. How many observations do I have? 5. 5 observations and 5 are odd, isn't it? So obviously third term is the middle term. And how do you think I have attained at third term? Suppose if I give you 99 terms, can you tell me what is the middle term there? As I have given you 5 terms, you are able to tell me. That is third term, you are telling me. But how about when I give you 99 terms? Are you going to cross them out this way? It's like crossing this and this and this. No, right? So you have to have some logic there. And what is that? Odd numbers you can never divide by 2. See, I have 5. Can I divide that by 2? With respect to the number of terms I'm talking, it should be an integer only. Positive integer, a natural number, it's what should be, right? Now 5 is there. So 5 I cannot divide by 2. So obviously I'll increase 5 by 1. That becomes a 6. 6 by 2, how much is it now? 3, isn't it? So now third term is my middle term set, isn't it? Now coming for 1, 2, 3, 4, 5, 6, 7, 8, 9. Now tell me. Now I have 9 terms. So 9 again, an odd number. So 9 I cannot divide by 2. I will increase 9 by 1. That is 10. 10 by 2, which is 5. Clear? So fifth term is my middle term. Understood? So similarly, if I have here, let it be if I have 1, 2, 3, 4. How many middle terms? Both 2 and 3 are my middle terms. If I have 1, 2, 3, 4, 5, 6, both 3 and 4 are my middle terms. Here, what am I doing? So if it is 4, yes, obviously I can divide 4 by 2, isn't it? So 4 divided by 2, how much is it? 4 by 2 is 2, the second term, and the third term, the very next term, you can consider, right? Coming for 6 also. So you can divide that by 2. That is your third term, and the fourth term. That also you can have. Understood? Clear at that? Right. So based on this fact, we are going to decide how many middle terms are there, if n is even or if n is odd, what actually happens and which term is exactly the middle term. That means if you observe your NC0, NC1, NC2, all the values are gradually increasing, attain some highest value, and they keep decreasing back again. Observe this, isn't it? So what did you observe in this? Let me show you. Yes, here. So here, do you observe 1, 4, 6, attained the maximum height 6, and then 4, 1. 1, 3, 3, attained the maximum height 3, and again reduce it to 1. Even here, if you observe 1, 5, 10, 10, 5, 1. Clear? So if you have 5, we have got 2 middle values. If I have 4, I have 1 middle value. Why do you think that is happening? Let us analyze what exactly is this. Right. Now, in the expansion, x plus a whole to the power n, number of terms is n plus 1. Agree with this fact, everyone? Right. Now, if n is even, what happens? Let us see. If n is even, my number of terms will be n plus 1. So, obviously, n plus 1 will be odd. Now, out of odd number of terms, tell me which one is your middle term. As I told you the logic, when odd number you cannot divide by 2, you increase that by 1 and divide by 2. So what is it? N plus 2 by 2 the term. Clear? So T n plus 2 by 2 will be the middle term. And here, as this is odd, you just get one middle term. Is that clear? Now, when I'm talking about n is odd, when n is odd, obviously, what is your n plus 1? N plus 1 is even. So the number of terms what we have is even number. So when n plus 1 is even, I can obviously divide by 2. So n plus 1 by 2 and n plus 1 by 2 plus 1th term, obviously the next term, isn't it? So this is n plus 1 by 2 along with t n plus 3 by 2th terms. So the term n plus 1 by 2 and n plus 3 by 2. So simple way to remember, now observe, if your n is even, n plus 2 by 2. If your n is odd, n plus 1 by 2 or n plus 3 by 2. Okay, so if it is odd, 1 and 3 are odd numbers, isn't it? If it is even, 2 is an even number. You can just remember it this way. Whereas this is the actual logic behind what we have done. Understood? So questions will be based on what is the middle term in the given sequence x plus a whole to the power something. So there you need to apply which term is your middle term and how to calculate. That is what you need to look into, right? So to understand the utility, to understand the applicability of this concept, so let us go with the problem 3x by 7 plus 2y whole to the power 10. Find the middle term in this expansion is our question. Now coming for the middle term, I have given you power 10. Now you tell me how many terms are there in the sequence. How many terms? 11 terms, isn't it? So 11 is an even number or odd number? Odd number. So odd number, obviously, we will have one middle term only. Answer is in your hands only. You can think about that. So you'll have just one middle term, right? So, and what is that middle term? That odd number you cannot divide by 2. Increase by 1 and get it. Or directly apply the formula when n is even. I've got n is even. What is it? T n plus 2 by 2. So your n is 10. So what is n plus 2 by 2? 12 by 2, which is 6. Hence, T6, term 6 is your middle term. But coming for what is the general term we have just now learned, isn't it? TR plus 1 is NCR x to the power n minus r and a to the power r in our expansion. Is that clear? Now, always remember when you have in the whole chapter, if you're talking about T6, R is never your 6. It should be written like 5 plus 1. Here, R is 5. This is a most important point to remember in the chapter, right? So if you have T6, T6 is not R is 6. It is R is 5. So T6 is written as T5 plus 1, wherein R is taken as 5. Clear? Now, this is nothing but NCR, x to the power n minus r, a to the power r. Here your x is the first element, and a is your next element. Observe. Right. Now just apply the formula. So that is your 10C R. R in the sense 5. Careful. Yes. 10C5. X, that is your 3x by 7 whole to the power 10 minus 5 and minus 2y to the power 5. Is that clear? So what is 10C5? How do you write 10C5? 10, you just decrease it 5 times. 10, 9, 8, 7, 6. By 5 factorial. 5, 4, 3, 2, 1. 3 to 6, 3 to 6 got cancelled. Right? 4 ones, 4 twos got cancelled. 5 ones, 5 twos got cancelled. Right? So whatever is left behind, that will be your answer. So either you can proceed with that or you can directly go with your answer now. Right. So 10C5, you can just leave it like this based on the options you proceed. Okay. So 10C5, this is a 3 by 7 to the power 5. And here you have a minus 2 to the power 5. So obviously it's a negative to the power. Odd is negative. So 2 to the power 5 and x to the power 5, y to the power 5. So this will be your answer. This is finding the middle term in the expansion of 3x by 7 minus 2y whole to the power 10. Clear? Yes, until now we were discussing just a binomial a plus b whole to the power. Now, if at all we have a plus b plus c whole to the power n, this still, as I said, can be converted to binomial by considering a plus b as one single term. You can consider that to be some d, isn't it? So that is a d plus c whole to the power n. You can consider now your trinomial automatically change it to binomial. Isn't it? So here also you apply the same logic, continuing this way. Now tell me another most important formula. You have to make it down. Now, most important formula, that is, if you have a plus b plus c so on till r terms are there, it might be some 10 terms to the power n or 15 terms to the power n. Even that, all that can be killed to one short answer. So number of terms in that expansion, in this expansion is nothing but, that is nothing but n. The number of terms in the expansion is n plus r minus 1 cn. Please do make a note of it. So if we have a plus b plus c all together till r terms, if I am considering, that is n plus r minus 1 c n. Suppose if I give you a plus b plus c whole to the power 10, let it be. I have given you 3 terms to the power 10. Now, how many terms do you have in this expansion is my question. Number of terms in this term, in this expansion. Now here we have our n equal to 10. And what is R? 1, 2, 3. 3 terms is what I'm including. R is 3. So just what is the formula? N plus R minus 1 Cn. So that is 10 plus 3 minus 1 C10. How much is it? 10 plus 3, 13 minus 1, 12 C10. And remember guys, 12 C10 is equally good as writing 12 C2. Why? What is the reason? Because if you are selecting 10 from 20, from 12 or rejecting 2 from 12, is it one and the same? Clear? And that rejection can be done only if you select those two, isn't it? Right? So either you call 12C10 or 12C2, one and the same. For our convenience, we are going to make it 12C2. What is the reason? 12C10, if I am writing, I have to keep coming down that 12 to 10 times by 10 factorial. That is very tedious for me, isn't it? But whereas when I do 12C2, it is nothing but I have to just reduce 12 two times, isn't it? So 12 into 11 by 2 into 1, which is how much? 66. Oh my God, 66 terms are there in this expansion. And now there is a small glitch in this expansion. This formula, most important, as I said, will not be suitable under one case. And what could that case be? Think about it. This expansion will not be suitable under one case. That is, see, suppose if I give you some x square plus 1 by x power 5 whole to the power 3 or something I am giving you, right? So some 13 I will give you, whatever it is. So such huge things is what I'm giving you. So in these, how many terms do we get? As I have given you just a binomial with a power 13. Yes, obviously you can say 14 terms are there, right? In this 14 terms, do we have repetition of the terms? That means, see, you might get x power 7 at so many places, isn't it? Because some combination of x square to the power some a into 1 by x power 5 to some power b, they get cancelled out and might result in your x power 7. And that might be repeated many times. Here, that x power 7 expansion, that x power 7 term might be repeated many times. Hence, this is not applicable when your when your terms has got a same variable. Remember, not applicable for same variable. Not applicable for same variable terms. If you have same variable, it is not applicable. Hence, I have written the formula also in the same way. A plus B plus C plus D plus so on till R terms. Understood? So these many terms, they should be of separate variables. You can have x plus 1 plus y plus 1 by z whole to the power 4. Also not a problem at all. Isn't it? Now tell me how many terms are there here? 1, 2, 3, 4. 4 terms inside. Clear? So your n is 4. R is also 4. So what is the formula? N plus R minus 1 Cn. So 4 plus 4 minus 1 C4. How much is it? 4 plus 4, 8 minus 1. 7C4. Is it equally good as writing 7C6, 7C3? Clear? So NCR or NCN minus R, one and the same. So it is equally good as writing NC3. So 7 into 5, 7 into 6 into 5 upon 3 into 2 into 1. So these two get cancelled. We have 35 terms in this expansion. Understood? So how to find out what is the general term is what we have learned. Next, what did we learn? We have learned what is the middle term in that expansion. And next coming for what is the number of terms in the expansion. Clear? So all these three things is what we have learned now till now. And the next concept is most important one, that is a numerically greatest term. What do you exactly mean by the numerically greatest term? Now, all this Pascal triangle, what I have written here is just the binomial coefficients, isn't it? They are just the binomial coefficients. That is your NC0, NC1, NC2. All this is what I have written. So when you observe these binomial coefficients, all these will be starting from minimum 1. They attain some maximum limit and then they decrease. Clear? Again, from here, attain some maximum height and then decrease. Even here, the same thing. So now tell me, is it like which term has the highest binomial coefficient? highest binomial coefficient will be there for the term in the middle place, isn't it? Clear? So like, if at all we find what is the middle term in this expansion, I can get to know what is the highest or what is the greatest binomial coefficient, right? But when I'm talking about greatest term, not just binomial coefficient, the constants also play a major role there, isn't it? Suppose if I give you 3x square plus, right, 5 whole to the power 10 or something like this I am giving you, right? So when I keep on increasing, the first term will be obviously NC naught 3x square to the power 10 plus next NC1 3x square to the power 10 minus 1. Let me take a 10 only. Yes. So power 9 and 5. Next, the other term will be 10C2, 3x to the power 8 and 5 to the power 2. So if I keep on writing this way, other than these binomial expansions, you'll have 3 power 9 into 5. You'll have 3 power 8 into 5 square. Next, you will have 3 power 7 into 5 cube. Next, you will have 3 power 6 into 5 power 4. So you keep on decreasing the power for the first one, increase the power for the next one. And in these, can anyone say which one will be the minimum or which one will be the maximum? Clear? So this concept is what we are going to decide now. See, if you take an example of the students in the class. So if I say the middle roll number, that is the numeric, that is the binomial coefficient, greatest binomial coefficient. But it need not be, this person need not be the topper of the class, isn't it? So if the roll number is in between, is exactly in the middle, that doesn't mean that that fellow is the topper of the class, isn't it? So if you have these two, so 1, 2, 3, 4, 5, 6, isn't it? So fourth and fifth positions are numerically greatest, or they are binomial, their binomial coefficients are greatest. Here, their binomial coefficients are greatest. At this point, they attain a maximum value and then drop down later, right? But that doesn't mean that this binomial coefficient, which has the greatest binomial coefficient, also has a greatest term there. Nothing like that, isn't it? Even the last one or the last before one might have a numerically greatest term. And how are we going to decide that? That we are going to know. Right, coming for the formula behind numerically greatest term attains at which position? Fifth position, sixth position, 10th position, at which position is the given expansion giving a numerically greatest term? That is given by what is R equal to n plus 1 mod x by 1 plus mod x. Here, observe carefully, I didn't mention a small x. I have mentioned a capital X, right? So what is the importance in writing that capital X is what I'm going to discuss using a formula, using a problem for you, right? Now, in this problem, now try to analyze what I'm writing. Now tell me, 3x plus 4y whole to the power 7 is what I have given you a question here. It's a binomial with a power 7. Number of terms in this? Number of terms in this expansion will be how much? 8 terms will be there, wherein your n equal to 7. Clear? N is 7. Number of terms in the expansion is 8, which means out of these 8 terms, you are getting different various combinations of 3x to the power 7. Next will be 3x to the power 6 and 4y to the power 1. Next, 3x to the power 5 and 4y to the power 2. So you keep increasing the powers of 3x and keep decreasing the powers of 3x and increasing the powers of you get various combinations. When you place the given values of x and y, you even get even more various answers. Out of all these 8 terms, you will definitely have one greatest term, or you might even have 2 greatest terms, which might be the same, right? So how are we going to decide that? So that one just apply in this. Now let us decide what is R equal to. As I gave you a formula, n plus 1 mod x by 1 plus x. And I told you x is not a normal x what we are dealing with. X has got some importance here. And that is nothing but express the given binomial as either 1 plus something or 1 minus something. Hence, you need to remove a 3x common. 3x, if you remove common, you will get 1 plus 4y by 3x whole to the power 7. So hence you just remove 3 power 7 x power 7 into 1 plus 4y by 3x whole to the power 7. Is that clear? Right? Now what is our x? Now our x is nothing but, after writing it in the form of 1 plus something, you please mention that x equal to 4y by 3x. Right? Now you are already given x and y values, just substitute. 4 times 1 by 2 by 3 times 1. How much is that? That is nothing but 2 by 3. Right? So now go with what is r equal to. I just got the value of x. So my x value is 2 by 3. This is what I am going to replace in the r. So at which term am I getting that? R. So r is nothing but n plus 1. What is our n? N is our 7. 7. In the sense n plus 1, that is 8 times mod 2 by 3 by 1 plus 2 by 3. Just resolve this. What do you get? 8 into 2 by 3 times, 3 by 5. Got it? Right. So that is your 16 by 5, which is how much? 3.2, right? 5 3 is 15, and right. Now, observe one thing. When you have your answer R to be in decimal, that means which is not an integer. Remember two cases. If r is not integer, if r is not an integer, you just have one middle term, that is nothing but the, yes, the integral part of r. So your r is 3.2 is there. So it is not an integer. So hence you will just take r equal to 3. This attains at r equal to 3. Clear? That means which term? Now tell me. When r equal to 3, which term has got the numerically greatest term? R equal to 3 annappudu T R plus 1 is the general term. Ante T4. Fourth term will be the numerically greatest term, not the third term. Remember this point. Okay. Now, what is the other point? Suppose as we got r equal to 3.2 here, it is not an integer. If it is not an integer, I said I will have one middle term, and that middle term is nothing but the integral part of the r value, what I got. Now, coming for if r is an integer. If r is an integer, how many middle terms do I get? Two middle terms I get. What are they? At r equal to 3, and the very next one, obviously 4 also. So that means which are the numerically greatest terms? T r plus 1, that is T4 and T5 will be your numerically greatest terms. Understood that fact? Clear? So please mention these 2 points very clearly. After finding your r, you need to understand if r is integer, how many middle terms? If r is not an integer, how many middle terms? Clear? So here itself I am writing, if r is not an integer, then you will have only one middle term. That is nothing but the integral part. Integral part will be nothing but your r. Clear? If r is an integer, so how many middle terms? You get two middle terms. That means if r equal to some 6 or something like that. So how many middle terms you get? 6 and 7. That means T7th term and T8th term will be your middle terms, will be your numerically greatest terms. Very sorry for that. Understood? So numerically greatest term is very much different from the middle term of the expansion. Middle term deals with binomial coefficient, whereas numerically greatest term, your middle term need not be your numerically greatest term always. Remember that. So where does that attain? That can be attained at which r? You are given r equal to n plus 1 mod x by 1 plus mod x. Wherein, what is that x? How do you get that x? When you represent your binomial expression in the form of 1 plus something or 1 minus something. That something is nothing but your x value, what we are dealing with. So your x is 4y by 3x. Just replace your x and y values, whatever way they are given in your question, replace them. Check out that that is your 2 by 3 is what you got. This x is what you are going to replace here in r. R is n plus 1 mod x by 1 plus x. So when you substitute here, we got a non-integral value. So whichever is not an integer, obviously 3.2 is not an integer. So that means my numerically greatest term attains at the integral part, that is r equal to 3. When r equal to 3, third term is never my term. When r equal to 3, what is it? Fourth term is the term what I'm talking about. T4 is what I have to calculate. So T4 is T3 plus 1. NCR plus 1 is my general term, which is NCR into x power n minus r into a power r. That is how you need to decide its numerically greatest term. Clear at that? Next, coming for the next concept, that is finding the coefficient of x to the power alpha, y to the power beta, and z to the power gamma in the expansion of ax plus by plus cz whole to the power n. Right. So what does that mean is, suppose if you have a plus b whole to the power 5. Right. Now tell me any term, let it be any term. Suppose let me consider n equal to 5 is there. Let me consider some r equal to 3. Right. So when r equal to 3, what is it? NCR, my general term I'm talking about. So NCR x to the power n minus r, or else a I will take. NCR a to the power n minus r, b to the power r, right? So what is it now? 5c2 a to the power 5 minus 2, that is 3, and b to the power 2. Now it's like, if I know this, yes, I am going to write it like a to the power 3 and b to the power 2. And the coefficient is nothing but 5c2, and that value is nothing but, you can go with the 5c2 is 5 factorial, or else you just reduce your 5 into 4 by 2 into 1. So this is the coefficient is what you can say, right? But when I give you, so now this 5c2, can I write it like NCR expansion? What is it? NCR is n factorial by n minus r factorial into r factorial, isn't it? So 5c2 is nothing but 5 factorial by 5 minus 2 factorial into 2 factorial. Observe, now are these 3 and 2 the same as these powers? Did you observe that anytime? Right? 3 power, and here also 3. Here you have 2 factorial, here also 2. Clear? So now coming for this formula applicability, what is it? Now, how do I write this formula? Think about it. So it's like finding the coefficient in this expansion, in the sense, what I can do here. Just a minute, let me, yes. So this is nothing but, this I have to go with my alpha plus beta plus gamma. See, observe, when you add this 3 plus 2, are you getting your power 5 or not? Understand that? 3 plus 2 is giving me 5. Hence, is it alpha plus beta plus gamma equal to 5? Or n here in this case. So I should have the condition like alpha plus beta plus gamma. When I add these 3, I need to get n. Hence, my coefficient will be n factorial by, obviously, alpha factorial, beta factorial into gamma factorial. That is the formula which I have derived just using this. So this is nothing but 5 factorial by 3 factorial into 2 factorial. Even if you observe, a plus b whole to the power some 7 is there, let it be. Right? So let me take some 6th term, or else let me take 5th term. So what is T5? T5 is nothing but T4 plus 1. Right? So which is nothing but, which is equally good as writing T4 plus 1. T4, R is nothing, R is your 4, right? So N is your 7, R is your 4, N is your 7. Now talk about expansion, NCR. So 7C4, A to the power 7 minus 4, and B to the power 4. And how do you write NC4? N factorial by N minus 4 factorial into 4 factorial into a cube and b power 4. Now here, do you observe here 3 and here 3, here 4 and here 4. So whatever you have powers as for a power and b power, the same will be the combination which you will find in the denominator, provided this 3 plus 4 is 7 there. So 7 factorial is what you have. Understood? Now I'm going to give another question. Try now. So this is my question. I am giving you 2x plus 3y plus 4z whole to the power 14, right? I want the coefficient of x power 6, y power 6, z power 2 in this expansion. How do I write it in one single step? Check it out now. Do you find 6 plus 6 plus 2? Is it 4? 14? Matching with that? 6 plus 6, 12. 12 plus 2, 14. Fine. Absolutely matching. Now what do I write? It is nothing but 14 factorial by, I would write how much? Yeah. Go ahead. Tell me what is it? Perfect. 14 factorial by 6 factorial into 2 factorial. Till here, fine. Now, I said that is nothing but your coefficient of x power 6. But I want the coefficient x power 6. But here you will have 2x power 6. That means into 2 power 6 there. Next, y power 6 in the sense 3 power 6 into 3 power 6 into 4z power 2. Hence, it is 4 to the power 2. All this will be considered. So, please be very careful while attempting such questions. 4 to the power 2, that also to be written carefully. Yeah. Understood? Because your x, y, z has got coefficients 2, 3, 4. All these will also be taken as powers there. So 2 to the power 6, 3 to the power 6, and 4 to the power 2 is what we have to consider. So this will be your final answer for that question. Understood? Now, when I'm talking about coefficient of x power 8, y power 1, and z power 10 in the same expansion, think about it. 8 plus 1 is 9. 9 plus 10 is 19. 19 do we have? Our whole power itself is 14, whichever binomial expansion you observe. And when you add all these terms powers, you need to definitely get the whole power there. That's a major rule behind that. Clear? So here, you just write not possible. Not possible to find the expansion of x power 8, y power 1, and z power n. You won't even find that expansion in that. That term, you cannot find it in the expansion there. Is that clear? Right. So let us solve few more problems on that. Right. The next concept is like finding the coefficient of sum of the terms x power something. Now observe here. I have written x power p and x power q here. So when I have x as a variable in the whole binomial expression, then I will be using this. If I want coefficient of x power s, some value, that means this might be x to the power 3, that might be x to the power 2, and n will be some 10 or something. I might need the coefficient of x to the power 8. So what do I do? So I cannot keep checking every term there, isn't it? So coefficient of x power s in ax power p plus bx power q whole to the power n. Where does it attain? Attain at which r is given by the formula np minus s by p plus q, where s is the which power is what we need. Clear? So now let me go for a problem. Yes, let me give you 2x square minus 3 by x cube whole to the power 5 is there. Right? And we want it for x to the power 8 coefficient. Tell me, what is the x to the power 8 coefficient in this expansion? So can we get x to the power 8? So that is 2x square minus 3 by x cube whole to the power 5. So we just have to check whether we get it or not. So how do I check? So how do I check whether I can get this x to the power 8 term or not? So what is the formula given to me? R equal to NP minus S by P plus Q. This is what most important. Now tell me what is N here? N is your 5. P and Q are the coefficients, are the powers of the first and the second terms there. So P is your 2, Q is 3. Just replace in the formula. And what is S? S is nothing but I want x to the power 8. So 8 is nothing but my S. So S equal to 8. Just replace. Now 8 into n, n is 5, right? So 5 into P, that is 2, minus S. S is nothing but 8 by what is P? 2 plus Q, that is 3. Now 10 minus 8, that is 2 by 5. Oh my God, R is 2 power 2 by 5. R is the position of the term there. That means either second, third, fourth, or 10th position. So there can never be a 2 by 5th position, or there can never be a minus 0.5th position or something like that, isn't it? So here in the whole chapter, our R to be a whole number only. R can be 0, that's the first term. R can be 1, that's the second term. R can be 2, 3, 4, but can it be 2 by 5? So R can never be 2 by 5. Hence, I will say that I can never get an x power 8 coefficient, right? Not possible, not possible to get it. Not possible at all. Now think about x power 6 coefficient. Can we get it? Think about that. So replace your S equal to 6 in this. Now tell me what is your R equal to? Just replace. So 5 into 2 minus 6 by 2 plus 3. How much is it? 10 minus 6. That is, 4 by 5. That is also not possible. So that is my 4 by 5, also not possible. Now try it for x to the power 5 coefficient. Do I get or not? Let us check. So x to the power 5 coefficient, in the sense S equal to 5 is what I have to replace. Now what is R equal to? 5 into 2 minus 5 by 2 plus 3. Yes, what did I get? So 10 minus 5, that is 5 upon 5. 5 upon 5, that is 1. Wow, wonderful. I will get R equal to 1 in the sense. Tell me which term is it? When R equal to 1, which term is it? Is it first term or second term or third term? When R equal to 1, that is your T2, second term. Clear? So your T2 is nothing but R is 1. 1 plus 1 is giving you 2 there. So now it is NCR, x to the power n minus R, and a to the power R. So that is your 5C. R is 1. Remember, R is 1. So 5C1, 2x square whole to the power 5 minus 1, and 3 by x cube whole to the power 1, right? So here you'll have 5C1 into 2 power 4 into x to the power 8 into 3 by x to the power 3. So hence you got these two together is your x power 5. So your coefficient is 5 into 2 power 4 into 3 is your coefficient. So for getting the coefficient, you have to decide what is the position in which that power will be coming. Hence you can go with R equal to NP minus S by P plus Q. Clear? Next, coming for what is the term independent of x in the expansion. So if it is term independent of x, which means that there is no x at all in that term. So for the term independent, so term independent of x, in the sense there is no x term at all, which means I want to the power x to the power 0. Here I consider s equal to 0. Clear? So what is r equal to? So your r is nothing. Yeah, R is same as NP minus S by P plus Q. So whenever you have a question based on term independent of X, you can just approach this. So for the same question, let us go with where is my term independent of X in the expansion? Let me write that expansion here. Right. In the expansion, 2x square minus 3 by x cube whole to the power 5. So this is the binomial expansion, what I'm giving you. So in this, what is the term independent of x? For this, my R will be NP. Your N is 5, P is 2, Q is 3, along with S is 0. There is no x to the power 0. Now R is what? NP. That is 10. S is 0 by P plus Q, that is 5, which is 2. Go ahead. So R equal to 2. R equal to 2 is which term? That is a third term. That is NCR. So 5C2, 2x square whole to the power 5 minus 2, and minus 3 by x cube whole to the power 2. So observe 5 into 4 by 2 into 1. again 2 cube x to the power 6 when you multiply into 3 square by x to the power 6. Observe beautiful thing what is going here. X power 6, x power 6 got cancelled there. You are left with just the numerical values. You just multiply them, you get your answer. So that will be a term independent of x considering s equal to 0. So whichever be the power for x they are asking can directly go with the position of the term given by r equal to np minus s by p plus q. That's the most wonderful formula one can have. Clear? Please make a note of this. Well, so altogether there are three parts in this binomial expansion. So the first part of binomial theorem is what which is done. So in this, what are all the topics that we have learned? That is how to get the coefficients or binomial coefficients of the terms in the expansion of x plus a whole to the power n. That is nc naught x to the power n into a to the power 0, obviously. Next, nc1. So all this expansion, how did we get it? Next, how many terms are there in a sequence? And then how many terms are there in any trinomial or even multinomial also we have done, right? So number of terms in, what is it? A plus B plus C plus D whole to the power n if I am giving. Here we have 4 terms. This is nothing but n plus 4 minus 1 Cn, isn't it? So even though it is not a binomial, we can still define how many number of terms are there in that. Later, after that, what did we learn? We have learned regarding defining what is its middle term. That means this binomial coefficients just numerically, not the numerically, gradually they go upward and then they stop down again. So what exactly is the middle term in that binomial expansion? So that is attained using whether n is even or n is odd. So if n is even, that is nc, n plus 2 by 2. N is odd, it is n plus 1 by 2 and n plus 3 by 2 terms I'm talking about, right? So that is the middle terms, and numerically greatest terms is different from the middle term expansions. So numerically greatest terms also we have done, which is not equal to your binomial greatest terms there, right? So yeah, let me go ahead with that. Yes. So this is the numerically greatest term what we have written, r equal to n plus 1 mod x by 1 plus mod x, wherein my mod x value is defined by taking either 1 plus x form or 1 minus x form of the given expansion. That capital X is given by the value there. After substitution, if you got integer or non-integer. If it is not an integer, that means 3.2 is what you got. Your r is nothing but 3. If it is an integer, that means that term and the very next term. Understood? So after which we have learned regarding finding the coefficients of the terms of x power 4, y power 3 and z power 6. So different combinations. We cannot just keep on guessing all that, right? So that also is given with a beautiful formula when you have alpha plus beta plus gamma equal to n. That is nothing but your n factorial by alpha factorial, beta factorial, and gamma factorial. Clear? So later we have discussed regarding what is the coefficient of x power 8 or what is the coefficient of x power 10 in the binomial expansion with the same same variable as x or same variable as y. Understood? So all these is the first part of the binomial theorem, term independent of x. That also you will consider your s equal to 0 and apply the same approach. R is np minus s by p plus q, right? So in the next video, we are going to have the second set of binomial theorem, right? So signing off now. Thank you so much. Bye-bye. Hello, everyone. Good morning. Welcome to Pace Digital. So this is yet another video of binomial theorem, lecture 2. So whoever did not complete watching the lecture 1, please do watch it and come back. Yes, in this we are going to discuss the numerically greatest term is what we have already done in the previous video, but the proof was not discussed, right? So how do you think that the numerically greatest term in the expansion x plus a to the power n is what we are going to attain through this? Now think about it. What do you mean by numerically greatest term, and what is the difference between greatest binomial coefficient? So binomial coefficients are, as I have just discussed, so they are gradually increasing. They will attain a position and then they gradually decrease. And that position where they attain the maximum height is nothing but, what is that? So that is a middle term. So at the middle term of all the expressions, of all the terms we have, the middlemost position will be containing the greatest binomial coefficient. But what about the numerical coefficient? See, numerical coefficient includes the x and a powers also, not just NC0, NC1, NC2. NC0, NC1, NC2 are all binomial coefficients. So when you apply some values for your x and a, obviously your middle term need not always be the numerically greatest term. Even your last but one term also can be a numerically greatest term. So that means out of all the given terms, there are some whole to the power n is given, isn't it? X plus a whole to the power n, in the sense, how many terms do we have? We have some n plus 1 terms. Out of the whole n plus 1 terms, there might be some numerically greatest term. Let me take some numerically greatest term. That's a general term to be some tr plus 1. All right. So tr plus 1 is my numerically greatest term, is what I am assuming. So obviously just before that and just after that, when you compare, obviously this should be the greatest, isn't it? So tr plus 1 should be greatest when you compare with the tr and tr plus 2, right? So let us discuss two cases now. So now my case 1 is tr is less than or equal to tr plus 1. See, why did I take a less than or equal to? Reason being, that numerically greatest term, you might have single one numerically greatest term, or the same term might also be repeated, which means you might have two numerically greatest terms also, right? For that reason, I have considered TR might be less than or equal to TR plus 1. That is my case 1. And case 2 will be what? TR plus 1 is greater than or equal to TR plus 2 is my case 2. Right, now let us solve. What is TR plus 1? I hope everyone knows what is the general term. Right, general term is NCR, x to the power n minus r, a to the power r. Now what about TR? TR is nothing but you just have to take one less there, isn't it? So NCR minus 1 x to the power n minus r plus 1, because n minus of r minus 1. So n minus r plus 1 into a to the power r minus 1. So I am trying to bring some terms on one side. So observe, I'm just bringing the numerical coefficients on one side. So I hope everyone must be aware of a rule. And what is that rule? I'm just giving it here. Observe, there is a small rule. Whenever we have NC5 by NC4, observe clearly, whenever we have NC5 by NC4. So one simple logic behind this is nothing but n minus 4 by 5. Clear? So n and n, if these both are same and you are selecting 5 terms and 4 terms, 2 consecutive with one bigger one on the top and smaller one in the denominator, when you consider, if it is NC5 by NC4, your answer is n minus 4 by 5. Similarly, if you have NC10 by NC9, it is same as n minus 9 by 10. So applying the same logic, so what do I do here? I will write NCR by NCR minus 1. Clear? Now this is less than or equal to, I am just applying mod on both sides because my inequality will not be changing there. Clear? So x to the power n minus r plus 1 by x to the power n minus r times a to the power r minus 1 by a to the power r. Right? Now, what are the things that are getting cancelled? So this is x to the power n minus r plus 1 by n minus r, that is x only, times a power m by a power n, which is nothing but a power m minus n. Right? Times a to the power r minus 1 minus r. So a to the power minus 1 less than or equal to n minus of r minus 1 by r, applying this logic there. Understood? So Now observe carefully. This part is what I am just simplifying a little further. N minus R plus 1, N minus R plus 1 upon R. So which is same as writing N by R minus 1 plus 1 by R. Got it? Right? So just right. So I am just splitting this as N plus 1 by R minus R by R. Clear? So N plus 1 by R minus R by R, that is 1. So that 1 I'm just sending it to the other side. So mod x by, this is nothing but x into a to the power minus 1. That is x by a plus 1 less than or equal to n plus 1 by r. Keep it aside. So this is one thing what we got. Right. Now let me go with the same kind of approach for the second set also. Right. I'm going to go with the TR plus 1 greater than or equal to TR plus 2. What do you feel TR plus 1? TR plus 1 is same as NCR x to the power n minus R a to the power R greater than or equal to what is TR plus 2 wherein R is your R plus 1 there. So NCR plus 1 x to the power n minus R minus 1 times a to the power r plus 1. Here also bringing the binomial coefficients on one side, rest all on the other side. So x to the power n minus r, a to the power r upon x to the power n minus r minus 1 times a to the power r plus 1 greater than or equal to ncr plus 1 upon NCR. Applying the rule, what is NCR plus 1 by NCR? That is N minus R upon R plus 1. And here what do we have? X to the power N minus R by N minus R minus 1. A to the power M by A to the power N. That goes to the numerator. That becomes X by A because that that will be coming down here. So X by A. Now try to observe. You have got some x by a and you have just split that r term separately. And how do we split this term now? What process do we have to apply? So if at all I have to split it, I need to have r plus 1 in the numerator, but I have minus r. See what I am doing here? So let me take a different color to make you understand better. That is minus 1 plus 1, minus 1 plus 1. Now observe what I am doing here. That is n minus of r plus 1 plus 1. These two together taken minus common upon r plus 1. So what do I get now? This is same as writing n plus 1 by, this one observe, n plus 1 by r plus 1 minus r plus 1 by r plus 1, which is 1. So finally, end product, what do we get here? All right. So this is same as writing x by a minus 1 comes here as plus 1 greater than or equal to n plus 1 by r plus 1. Understood that? Till that, is it clear? So from here, I'm just taking a flip on both sides because I want the position of the R. Like what is the term which we are talking about, which we are thinking about is based on getting the value of R. So how do I get R? So observe these two, n plus R by R is there. And here we have n plus 1 by R plus 1. So R is the factor what I need to get. So for which I'm just taking a flip on both sides. Right. So how do I do it? So I want what is R, isn't it? So R is less, this is sent there and that is brought down here. N plus 1 by 1 plus x by a. Is that clear? So R is less than or equal to n plus 1 by 1 plus x by a from the first case. And what about the second case? Right, let me write. Yeah. So here your r plus 1 is greater than or equal to n plus 1 upon 1 plus x by a. Right? But what is it we are talking about? We are talking about r not r plus 1. Right? So better take it this way. So r is greater than or equal to n plus 1 by 1 plus x by a minus 1. Right. So let us give some variable to this. Some variable, some letter is what I am going to give for n plus 1. Let me consider this as m. n plus 1 by 1 plus x by a. Let me consider this as m. So from the first case, I ended up with r less than or equal to m. From the case 2, I ended up with r greater than or equal to m minus 1. See, all this we are doing because while we are doing the problems, we are not going to do all these. All this khichdi is what we will just complete it now, and just the formula, direct formula is what we have to apply there. Understood? So r is less than or equal to m and r is greater than or equal to m minus 1. Together, how can I frame an equation? And an equation can be formed by taking r is less than or equal to m, and as this r is greater than or equal to m minus 1. So what did I conclude? So my conclusion is the value m, which is same as n plus 1 by 1 plus mod x plus a. This can be, your r can be lying in between m minus 1 and m. And now I don't know whether m is an integer or not. Do I know that? After doing all this calculation, I will be getting two cases wherein n belongs to integer and the other case wherein m is not an integer. Okay, suppose m is not an integer is my first case and m belongs to integer is my second case. Okay, m is not an integer is my first case. So let me consider just a small example. Suppose after all this substitution, I got m equal to, let it be some 7.3 is what I got. I got m equal to 7.3. Now what could be m minus 1? Tell me. M minus 1 is 6.3, right? Now tell me, your r is ranging from minus 1, m minus 1 to m in the sense. So 6.3 less than or equal to r less than or equal to 7.3. And we definitely know r is an integer only. Positive integer, isn't it? R is the position of the term there. It's a natural number there. So what is the natural number lying in between 6.3 and 7.3? Not only natural number, r equal to 0 also can be possible, and see 0. Whole number also is possible there. So it should be a whole number definitely. Now in order to get that, so what can I conclude? R is nothing but 6.3 to 7.3. In between the whole number, what is it? That is 7 only. So here R equal to 7. When R equal to 7, which term is the numerically greatest term? Think about it. The term which is numerically greatest term is T8. How can we get T8, T7 plus 1, R plus 1? Clear? Understood? So based on the options, carefully proceed. Now, when your m is an integer, what is the case? Suppose when m is an integer, all right. So m equal to some 3 is what I got, right? So r is less than or equal to 3 minus 1, 2 and 3. So r can be both equal to 2 or 3 is what I can consider there, isn't it? So when m is an integer, it can be equal to, r can be 2 and 3. So the numerically greatest terms is what? 2 numerically greatest terms we got when m is an integer. Understood? So only thing, what you need to remember while doing numerically greatest term is finding the value of m is most important. What is the value of m? N plus 1 by 1 plus mod x by a, wherein, in which expansion? This is the expansion of x plus a whole to the power n. Is this clear? So after finding the m, consider two cases. When m is not an integer, when m is an integer, you might get an integer or you might not get an integer. When you got an integer, what does that mean? You have two middle terms. What are they? That are the same r and one less. If m is not an integer, then what is it? If it is 7.3 is what you got. It lies between, yeah, or you can just take box x, step x function, or step 7.3, which is nothing but 7. So your m equal to step m, step m. Clear? So r equal to step m is what you consider there. Understood? Right? So this is a complete proof for the numerically greatest term in the expansion of x plus a whole to the power m. Got it? Right. Right now, let's go with the problem. Find the numerically greatest term in the expansion of 2 plus 3x whole to the power 10, where x equal to 11 by 8. So in order to find the numerically greatest term, we just now found we need to calculate what is the value of m. So m is nothing but n plus 1 by 1 plus mod x by a. So n plus 1, what is your n? Tell me. N is a power there, so n is 10. X is 3x and a is 2, you can consider. So mod x plus a. So mod x plus a is 3x by 2. Now coming for 3 by 2 times. You're already given a value for x, that is 11 by 8. All right, which is 33 by 16. Right, which is same as writing 2 point something. So m value is 2 point something, which is a non. So 2 point something in the sense it is a non-integer, hence what can we consider our R to be? Step M, which is step 2.2. Hence your R is 2. Clear? So R is taken as 2 there. Right. Oh yeah, please correct the mistake here. Yeah, so we have just calculated our x by a, which is 2.06, right? So now I'm going to replace in my m value, that is n plus 1 by 1 plus mod x by a, which is n plus 1 is 10 plus 1 by 1 plus this 2 point something. So 11 by 3 point something is what I got, a 3.54 to be that, which is not an integer definitely. Hence, my R is a step M, that is R is step 3.54. Hence, your R equal to 3. Did you all understand this? Right. So, when R equal to 3, in the expansion, 3x plus 2 whole to the power 10, R equal to 3 is what you take and write the general term, which is 10c3 x to the power 10 minus 3 and 2 to the power 3. Just substitute the values. So 10 C3, you can leave it like that or you can still more further simplify. 3 power 7 times your x is 11 by 8 whole to the power 7 times 2 cube. So we can write it to be 3 into 11, 33 whole power 7 upon this is 2 power 3 whole power 7. So 2 cube whole power 2 power 21. 21 there and 3 here, right? So, yeah, or else that also you can consider to be 8, isn't it? So, we can make it 8 to the power 6 also. Done. That also can be done, right? Fine. So, yeah, setting up with your answer here. All right. That is 10C3. So your answer can be written anyhow. Your 8, you can leave it outside. 10C3, 33 by 8 whole to the power 7. So accept it. So based on your options, you just check your answer and proceed accordingly. So that is how you find your numerically greatest term in the expansion of x plus a whole to the power n. So what did we do here? We have just found what is the value of m and what is the m value, that is n plus 1 by 1 plus mod x by a. That m, if it is turning out to be an integer, you have two terms. Suppose if it is 3 only, then r equal to 3 and r equal to 2 will be your two numerically greatest terms. But when r equal to 3 point something, it's the step x function, that is a step 3.59, which is nothing but 3, r equal to 3, and you get just give your general term there. There ends your question, right? Now, coming for the three successive terms of AP are three successive binomial coefficients. So let me talk about the binomial coefficients, three successive binomial coefficients as NC, yeah, NCR, NCR minus 1 and NCR plus 1. So let these three be three successive binomial coefficients in AP. Right. So how do I get a relation between all these three binomial coefficients? So if you apply this one law for any problem, that will sort out very easily. So for that, we are just going for a small derivation, how to find the relation between these three, if at all these three are in AP. And not only that they are in AP, they will never be in HP, GP and any other progressions. Three successive binomial coefficients will always be in AP only. Now, when the three terms are in AP, obviously the condition is 2 times middle term is sum of first and last terms, isn't it? So this minus this equal to this minus this, isn't it? Suppose if I say these are A, B, C, B minus A equal to C minus B. Hence you got 2B equal to A plus C, isn't it? So 2 times the middle term is sum of first and the last terms. Clear? So 2 times NCR is same as writing NCR minus 1 plus NCR plus 1. Now what I am going to do here is I am going to divide by NCR on both sides. NCR minus 1 by NCR plus NCR plus 1 by NCR. Right. So we have just known what is the rule behind writing such things, isn't it? Observe here carefully. Just a minute. Let me take a different color. Right. When I talk about NC5 by NC4, we have just discussed it is same as writing N minus 4 by 5. Clear? Bigger, but the condition is what? You need to have the bigger by the smaller. So now you tell me what is NCR plus 1 by NCR, which is same as writing bigger by smaller only. I have considered that, isn't it? So N minus R by R plus 1. That is my first thing. Now, talking about the first one, this part, when I'm talking about, I have smaller quantity by the bigger quantity, but I know the rule for, yeah, let me consider writing here. Fine. So if it is NCR by NCR minus 1, I know what that is. That is nothing but same as writing N minus N minus of R minus 1 by R, which is same as N minus R plus 1, N minus R plus 1 by R. So these are the two things what I am going to apply in my given question there. Right. So here I am going to write. So when I got NCR by NCR minus 1 as this, NCR minus 1 R by NCR is just a flip there. Right. So you can consider R by N minus R plus 1 plus what about this part? This is same as writing NCR plus 1 by NCR is same as writing N minus R by R plus 1. Right. So after writing like this, take their LCM, cross multiply, expand everything, solve it very carefully, send it to the other side. After all that solving, you end up with a rule. Whenever you have NCR minus 1, NCR and NCR plus 1 are three consecutive terms of AP, directly go with this formula that is, which we have just now derived. So that is N minus 2R whole square equal to N plus 2. Clear? So N minus 2R whole square equal to N plus 2 gives you the required result there. Understand? Yes. Now just let us solve a small problem based on this. That is, if you have your x to the power 9, x to the power 10, and x to the power 11, all these three are consecutive. And this is 1 plus x whole to the power n expansion. Now prove that you have a relation here, which we need to prove. Now, how do I prove that? Now think about it. When x to the power 9 in the sense its numerical coefficient, what is it? NC 9, NC 10 and NC 11. All these three are in AP, right? So whenever they are in AP, what is the condition just now what we have derived? That is same as N minus 2R whole square equals to N plus 2. Remember this, right? So N minus 2R whole square equals to N plus 2. And in our relation, the previous one, observe, we have NCR minus 1, NCR, NCR plus 1. So the middlemost value is what we are considering for, this is what we are considering for my R there, right? Yeah, lost that page. Okay, right. So this is the problem based on three consecutive terms of AP being three consecutive binomial coefficients, isn't it? So I am given x power 9, x power 10, and x power 11 are the binomial coefficients which are in AP, we need to prove this condition. And whenever they are in AP, obviously the middle term is what I'm considering as R equal to 10. So because when you observe there, my R is my middle term which I considered. Hence, this is also R equal to 10 is what I'm considering. And what is the formula? If at all they are in AP, the most beautiful formula, wonderful formula, which you can do nothing there, is n minus 2r whole square, which is same as writing n plus 2. Is that clear? So n minus 2r whole square is n minus n plus 2. Here, your n is what we don't know. Yeah, r is same as 2. Fine. You just expand this. So, n minus 2r, which is 10, the whole square is your n plus 2, right? Yeah, so 2r in the sense 20, I guess. Yeah, n minus 20, the whole square is n plus 2. So here you can write n square minus 40n plus 400 equals to n plus 2, right? So you can go with your n square minus 41n plus 398 equal to 0 is your required end result for the problem. Understood? So we have done all this simplification whichever is necessary prior and we got a beautiful formula. Right? So that we will just apply in the second one. That is enough, isn't it? So we are just going to apply there. That is far enough. Understood? Even for the previous ones also, we have done all this derivation and got one value, that is my m equal to n plus 1 by 1 plus mod x by a, and we just applied that in the formula. So derivation to be done first, hence you can apply that at a later stage for an easy calculation, which really saves your time. You cannot do the whole process again. Even if you do the whole process, you will be getting, but that will be adaptable for your board exams, not for your competitive exams, isn't it? So for competitive, you need to have a quick access on the problem. So looking at a problem, you just have to have a thought that yes, so this is the formula, that is n minus 2r whole square is n plus 2 is what I have to apply whenever three terms are in AP, right? Even in the yesterday's class, we have discussed regarding these problems on finding the coefficient of the given terms in the expansion. Right. So coefficient of a to the power, yeah, a power 4, b cube, c cube, and d in the expansion of so and so. So what are the things that we need to just check? That is, when you add the powers, you are supposed to get the whole power there. Alpha plus beta plus gamma plus delta should be supposed to be a 10 there. Right? So now observe, this is power 1 I consider. They didn't give us. So 4 plus 3 how much? 10 is what we already have, and the whole power is 10 there, right? So this is supposed to be 2 dear. Okay, in the question we have a 2, very sorry. So this is a 2. Right, so 4 plus 3 plus 2 plus 1, 4, 7, 9 and 10. So we have a 10 as a power. So alpha plus beta plus gamma plus delta equal to 10 is perfectly matching there. Right, so answer is direct answer is what I'm going to write now, which is, let's go with that. 10 factorial upon, so 4 factorial, 3 factorial, 2 factorial, and 1 factorial to a to the power 4 and minus b to the power 3, c to the power 2, and minus d to the power 1. So this minus and you have another minus here. They both just come out and dissolve into a positive sign. So final answer is only this 10 to the power 4 factorial by 4 factorial, 3 factorial, yeah, whatever we get, the final answer is what you calculate and get it, you'll get it. All right. Right, coming for the next one, a cube. Now, this is, you have got a power 12. So, 5, 9, 12. Yes, we already got it. So, obviously, 12 factorial by, this is 3 factorial, 4 factorial, and 5 factorial. That's how you get it. Clear? Times your a power 3, b power 4, c power 5. So the coefficient is same as writing this. Now we are going to go with another problem. Yeah, so think about this question. So coefficient of x square, y cube, and z square. So 2, 3, and 2. When you add, yes, you're getting a perfect 7, no issue at all. So final answer 7 factorial by 2 factorial, 3 factorial, 2 factorial times. Observe here carefully. That is 2x to the power 7. So 2 power 7 times my, oh no, 2 to the power 2, isn't it? Yes. So this has got a power 2. The other one, y, will be having a power 3. So minus 3 to the power 3. And that is z, that is 1 to the power 2. Right. So final answer is what? You can write it. Right. Now for this problem, coefficient of x square y cube in the expansion 1 minus x plus y whole to the power 20. Right. So the whole power is 20 and we have x square and y cube. So x will have a power 2 and y will have power 3 and 1, I don't know what I'm supposed to have there. Think about it. When you add all the three powers, you are supposed to get a 20, which means 3 plus 2 is already 5 there. So 5 plus how much can give you that 25 plus 15 only. So maybe I will take a power 15 here. Understood, right? Now my final answer, we will be writing 20 factorial by 15 factorial, 2 factorial, 3 factorial. While you're writing, yes, 1 power 15, right? So that you can write it as a minus x, yeah, whole to the power there. You can write, yeah, without any x also we can write. So directly minus, anyhow, that is the power of whole square and all, we will be getting it. Right. So this to the power 2 and 1 to the power 3. So your final answer is that. Right. So 20 factorial by 15 factorial, 2 factorial, and 3 factorial. Right. Now the question comes for the next question. Coefficient of 8, a power 8, b power 4, c power 9, and d power 9 is what I'm supposed to get. 8, 4, 9, and 9 is what I'm supposed to get. I am having 4 terms. Now we need to choose my alpha, beta, gamma, delta in such a way that, see, observe A, B, C, A, B, D, A, C, D, and B, C, D. To the powers, if you consider some alpha, beta, gamma, and delta, what are all the main conditions that you need to match? Think about it. So first thing, my alpha plus beta plus gamma plus delta equal to 10. This is what I'm supposed to have, right? Clear? Right. Now, when you just see what happens here, a to the power 8 is there, b to the power 4, c power 9, and d power 9. How are we supposed to guess them? So a power, how much are we getting? Think about it. A power alpha here, a power beta here, a power gamma. So can I just, while I am multiplying a power, do I get alpha plus beta plus gamma into b to the power alpha, b power beta, b power delta. So b to the power alpha plus beta plus delta into c to the power alpha, c to the power gamma plus c to the power delta into d to the power how much now? D to the power, yes, beta, d to the power gamma, d to the power delta. Right. Now, how am I going to solve this? Let me connect the chart. Right. So, observe here carefully, a to the power 8 there. But a to the power alpha plus beta plus gamma. So, can I take alpha plus beta plus gamma equal to 8? Similarly, alpha plus beta plus delta equal to 4, as b to the powers is what I'm equating. And alpha plus gamma plus delta equal to 9. And beta plus gamma, yeah, plus here, beta plus gamma plus delta will be equal to d power, d power, d power 9 there, right? So you just subtract one of these equations and just check alpha plus beta plus gamma is 8 in the sense delta equal to 10 minus 8, 2. Clear? Now alpha beta delta is 4. Alpha beta delta is 4. So your gamma is 6. Right? Next, alpha gamma delta is 9. Alpha gamma delta is 9. Hence, your beta is 1. Right? 6, 7, 8, 9. Obviously, the other one will be another one. Yeah, which one we will, yeah, beta, gamma, delta. Beta, gamma, delta. Hence, your alpha will be equal to 1. So, that's it. There ends the case. So, hence, what are your answers here? So, your alpha, beta, gamma, delta will be your 1, 1. Gamma is 6 and delta is 2. So, these are the 4 values. Fine. Right? So when you add up all these, you got a 10, right? So it's now final answer is what I'm writing 10 factorial by 1 factorial, 1 factorial, 6 factorial into 2 factorial. And now you just apply all this A, B, C to the power 1, A, B, D to the power 1, next A, C, D to the power 6 and B, C, D to the power 2 there. There is your answer. So hence your final answer will be your 2520 there. Understood? So 2520 will be your final answer. 10 factorial by 1 factorial, 1 factorial, 6 factorial times 2 factorial. Yes, now the question is regarding coefficient of x power 10 and x power 11 in the expansion 1 plus 3x plus 2x square whole to the power 6. Now this is our question. So can we be able to factorize this? If at all we are able to factorize that, we will try them. So unfortunately, this question will not be factorized, right? So what is my next option for that? So yeah, I am given the question like, right, so I have 1 plus 3x plus 2x square whole to the power 6, wherein I can take something common. That is 1 plus x if I take common, that is 3 plus 2x whole to the power 6. Now, this is same as writing 1 plus some y whole to the power 6 expansion is what I will consider, wherein my y is x times 3 plus 2x. Understood that? Right. Now, what about the expansion of this? So 1 plus y whole to the power 6 expansion or 1 plus some nonsense whole to the power 6 expansion. So let me just write that expansion here. So the whole expansion is what I have written here. So 6C0, 6C1, 6C2, 6C3, 6C4, 5 and 6. So the whole expansion is what I have written for 1 plus x into 3 plus 2x whole to the power 6. Now we need x to the power 11. Let me do x to the power 11 first, right? Now for solving x to the power 11, tell me x to the power 11, how can you get it? Tell me what is the highest power in this? You have x power 4, right? In this term, x power 4 is there. And from here, you will max to max get x to the power 4. X to the power 4 into x to the power 4, that is your x to the power 8, right? Even if you observe here, let me draw a line here. So even if you observe here, x to the power 3 into x to the power 3 is the highest there. So x to the power 6. So we need x to the power 11. So obviously I have to go with somewhere here. Now when I consider last but one term, x to the power 5, and here from this expansion, the highest power is x to the power 5. X power 5 into x power 5 is x power 10. But I need x power 11. So how can I get x power 11 from the other one, isn't it? So from this is what I am going to derive from, only from this term is what I am going to derive my x to the power 11. Observe x power 6 is already there. Now, what do I need? I need x to the power 5 to make it x to the power 11, right? Now, in order to get x to the power 11, that is x to the power 5 here. So, I want x to the power 5 in that expansion. X to the power 5 in the sense I will get it at 6C5, isn't it? So, here I will have 6C5, 6C5, which is a 3 to the power 6 minus 5 and 2x whole to the power 5. Clear? And you already have x power 6 and 6c6. So this is what your coefficient of x to the power 11. This is coefficient of x to the power 11. What all do we have? 6c6, that is 1. 6c5, which is same as writing 6c1, that is 6, times 3 into 2 to the power 5. Right? So that is 18 into 32 will be your final answer there. Understood? That answer, you just take care. I'm not writing. 18 into 32 is what you can do, right? Now, coming for what if it is x to the power 10 expansion. Now, I want x to the power 10 in all this. So, as we have just now seen, highest here is to x square into x square, x power 4. Highest here is x cube into x cube, x power 6 only. Here I have x power 4 into x power 4, that is x power 8 only. Here is what I have, x to the power 5 into x to the power 5, right? This is the term where I can get, that is 6c5 x to the power 5 into 3 plus 2x whole to the power 5. From here I can get it. Also, x to the power 10 is what I want, isn't it? So 10 kavali ante, obviously I have a 6 here. I need more 4 from there. That also I can get it. So I will write 6c6 x to the power 6 and 3 plus 2x whole to the power 6. In this, I need to have x to the power 4 in this expansion. X to the power 4 in that expansion. Then it results in x power 5. Right. Now, these two, for answer for this term will be x to the power 5 anyhow there. 3 plus 2x whole to the power 5 is what we have. Obviously, when you multiply, what do you get there? So here I want an x to the power 5 coefficient in that particular term. So let me write 6c5 x to the power 5 as such. And now in this, I am going to write x to the power 5 expansion, which is 5c5, right? So 5c5, 3 to the power 5 minus 5, which is 0, and 2x whole to the power 5, right? Plus, I anyhow have 6c6 into x power 6 and I want the x power 4 expansion in. That is 6c4, 3 power 6 minus 4 into 2x to the power 4 is what I need there. That's it, right? Clear? So this will be your 6c5 in the sense it is same as writing 6c1. Isn't it? 6c5 or NCR and NCN minus R1 in the same. So this is 6 into 5c5 is anyhow 1, 3 power 0 is 1 and 2 to the power 5, right? So 2 to the power 5, 32 into 6 from the first set plus here where do we go with 6c6 is anyhow 1 and 6c4 is same as writing 6c2 which is 6 into 5 by 1 into 2, that is 6 reduced by 2 times 6 into 5 by 2 factorial times 3 square into 2 to the power 4. So all the resolving part you do it. Final end result is not my job, it is your job to solve it, right? So all this calculation part, you just solve it very carefully. If you can take terms common and solve it, it would be a better one. Understood? So in order to get your x to the power 10 and x to the power 11 in the expansions of this, 1 plus something is what you have there. So expand it carefully and think where do we get all these expansions. Is that clear? Right. Yes, coming for the next question, that is the term independent of x in root x minus k by x square whole to the power 10 is 405. So they said term independent of x. Now, in order to get any power of x, whenever you have a binomial with x power something and x power something here, x to the power p and x to the power q. Here, now let us talk about what is p and what is q. Do you remember the formula? Right? So that is your NP minus S by P plus Q, wherein what is S? S is nothing but which X power value is what you need, which of the powers is what you need for the X is what your S takes, and P is what? The first one. First one, that is P is your root X in the sense X to the power 1 by 2. Q is X square, that is your 2, right? So now you just carefully put in there your n equal to 10 is already given for you. NP minus S. So 10 by 2 minus S, that is 0. As they said term independent of x, that is x to the power 0, I am talking about. The same question can be asked for what is the term with a coefficient of x to the power, what is the coefficient of x power 7, they might ask. Like, so for x to the power 7, in this sense, you need to understand that x power 7, 7 is what you need to place in the place of s. upon p plus q, that is 1 by 2 plus 2, which is a 5 upon 5 by 2. Hence, 2 is your answer there, right? So this will be the term independent, which is nothing but same as your R, isn't it? So your R is 2 in this case. And now how should you proceed with that? So now that you got your R is 2, so your T3 is nothing but the term independent. The third term is the term independent of x, right? So R is 2. So obviously 10C2 root x to the power 10 minus 2 and minus k by x square whole to the power 2. Understood? So now coefficient of this is what when you observe, yeah, 10C2, that is 10 into 9 by 2 into 1 times, that is x power 4 and this is x power 4 gets cancelled anyhow, and k square is your 405. So solving k square, what do you get your answer to be? K square equal to 9 you'll be getting. So k equal to plus or minus 3 will be your answer there. Understood? So that's how you solve the problem term independent of x. Please do remember the formula NP minus S upon P plus Q, right? Now for the question, term independent of x in x plus 1 by x power 2 by 3 minus x power 1 by 3 plus 1 minus x minus 1 by x minus x power 1 by 2. Yes, I am right at writing the question. Right. So you are having so much of glitch in your denominators there, isn't it? So you have 3 terms in the denominator. It looks like some square. See, observe. X to the power 1 by 3 whole square can I write? Plus 1 to the power also 2 I will write. Minus x to the power 1 by 3 I am going to write. Okay. I'm just trying to make you understand what is the denominator of the form. Right. So that is x to the power 1 by 3 whole square. And this is 1 square, a square term with one more term. So now does it look like a square plus this is my b square? And is this in between ab or not? Wherein your a is your x to the power 1 by 3, b is just 1. Right. So whenever you have a square minus ab plus b square, think about how to rationalize them. Right? See, try to understand a minus b, a plus b of a square minus ab plus b square is a cube plus b cube. This is what you have already learned in your class 8, 9 and 10, right? Now, what is your a minus b of a square plus ab plus b square, which is a cube minus b cube. Always do remember these are most important formulae. A cube plus b cube always starts with a plus b. And here you'll have a minus ab term. And a cube minus b cube always starts with a plus b. And there you'll have a plus ab term. Understand? Now, which one is this correlating with? The first one or the second one? Think about it and tell me. You have a square minus ab plus b square. So the first one is what I have to correlate with. Hence, I need to have a plus b. But I don't have a plus b. What should I do? I cannot keep quiet, isn't it? So, x plus 1 by x to the power 2 by 3 minus x to the power 1 by 3 plus 1 ki, I can multiply and divide with the term what I need. What is that which I need? I need a plus b, isn't it? So, I need this term. A plus b is what I need very bad. So, what is it? That is nothing but x power 1 by 3 plus 1 is what I need. Here also I will multiply with x to the power 1 by 3 plus 1. That multiplication and division is what very much needed there for the question. Clear with the first part? Right. Now, how does this turn out to be? Tell me. So, this is x to the power 1 by 3 and x plus 1. So, that is my x to the power 1 by 3 plus 1 times x plus 1 upon. Does it look like a plus b of a square minus ab plus b square, which you can always substitute it to be a cube plus b cube. A cube in a sense, x to the power 1 by 3 whole cube. X to the power 1 by 3 whole cube. So if you want, you can write it. A cube is same as writing x to the power 1 by 3 whole cube, which is same as x, isn't it? A cube is your x, b cube is 1. Right? So a cube plus b cube. Now observe the cancellation which is going on. So x to the power 1 by 3 plus 1 is what you are left with. Now going ahead with solving the second bit, how do I solve? Coming for the second bit. Now coming for x power x minus x to the power 1 by 2. So what is the rationalizing factor of a minus b? Both, see, observe here, they are in terms of roots. Square root in the sense when you have a minus b, if you multiply with a plus b, your root just vanishes because that is a square minus b square. Root just vanishes there, isn't it? So rationalizing factor of a minus b is always a plus b. Hence, what do I multiply here with? X minus x to the power 1 by 2. You have your numerator this. And what is the thing that I'm going to multiply and divide with? When you have x minus x to the power 1 by 2, multiply and divide with x plus x to the power 1 by 2. Even there, x plus x to the power 1 by 2 is what you do there. Now, these two together, how much they do? They result to a plus b of a minus b, which is a square minus b square. That is x square minus x to the power 1 by 2 whole square. And your numerator is x minus 1 of x plus x to the power 1 by 2. Now, observe, is this same as writing x square minus x to the power 1. Now you can just take something common, that is taken x common, x minus 1. Just cancel them down. You have a minus sign in between, right? And now observe there carefully. Final step, please do mention carefully. So x power 1 by 3 and plus 1 is what I have written there. Minus of, in the bracket, observe we are left with x plus x power 1 by 2 by x. X by x is 1 plus x power 1 by 2 by x. So finally x power 1 by 3 plus 1 minus 1 minus, how much is this? X to the power 1 by 2 minus. So that is x to the power minus 1 by 2. So these both are getting cancelled. So I am left with what? X to the power 1 by 3 minus x to the power minus 1. Right. So this x to the power minus 1 by 2 is what I have written like 1 by x to the power 1 by 2. And the question says term independent of x in this whole to the power 10. So I got to the form of, now what do I want? Term independent of x in the sense x to the power is 0. So my s is 0. My formula for finding the coefficients is r is np minus s by p plus q. Here, what is your p and q? P is your 1 by 3. Q is your 1 by 2, S is your 0, and N is 10. Just apply all these in one formula. N 10 times P, that is 1 by 3, minus S, that is 0, upon P plus Q, 1 by 3 plus 1 by 2. So 10 by 3 times 3 to 6 by 5. All right, this will be 2. So my R is 4, right? So which term is independent of x? Is it the fourth term, can you say? Think about it. It is in the fourth term. It is fifth term. So only fifth term will have your R to be 4 there. Understood? So fifth term will have your R to be. So from there you can get the term independent of x in this expansion. So wherever you have some critical kind of problems, you just think about rationalizing multiplication with cube roots or square roots if you have. Think about the rationalizing factors, multiplying with the rationalizing factors. They get resolved to few simpler things. From there is what you can apply your synopsis, right? Right. Now coming for this question, number of terms in the expansion of root 3 plus 8 root 5 whole to the power 256. So what do you mean by number of integral terms? Integral terms are the powers or the terms without any roots under them. So the terms which are free from the roots. So integers is what we need. So we don't need any square root of or cube root of or fifth root or 10th root, because in all these terms, now how many terms do we have in this expansion? Tell me. 256 is the power in the sense you have 256 plus 1. That is 257 terms is what you have. Is it possible to find out from the 257 terms how many are integers, how many are non-integers? So think about it, right? So if at all it is an integer, which means you're not supposed to have that gap there. That under root, square root, cube root, or fifth root, or 10th root is what you're not supposed to have. So in order to eliminate that, the first one given is a square root given. And what is the other one? Yeah, this is square root in the sense power 1 by 2. Cube root in the sense power 1 by 8. Sorry, 8th root in the sense power 1 by 8. Right. So please do take the LCM of these two. Right. So for 1 by 2 and yeah, for 2 and 8 is what it should be like. If at all it is not supposed to have a root, which means it should be definitely a square or power 8. So which means it should be in common to both of these, isn't it? So for 2 and 8, what is the LCM is what you just think about. So the LCM of 2 and 8 is what you are getting 8. Now hence what you do is that means what out of every 8 terms you will definitely get one number which is divisible, which is perfectly an integer. Understand? Clear? So after 8 terms is what this set is repeating. After 8, you get one integer. After another 8 terms, you get another integer. Another 8 terms, you get another integer. So the whole 257 terms will be divided into all these 8, isn't it? So now what you're going to do is this 256. Why am I doing 256 in the sense? Actually 257 terms, right? So, but I'm dividing 256 by 8. Why? Because every term will have it if it is your x plus a whole to the power n, or let me take a plus b. A plus b whole to the power n expansion has nc naught a power n, nc1 a b square, nc2 a sorry, a to the power n minus 1 into b. Next, nc2 a to the power n minus 1 into b square. So on like this. If you keep on solving, one first term will not have b, and one last term, that is your ncn b power n, which will not contain a. So only in the last and in the first terms you will just get one of these values of a and b. Rest all the other terms in between will have a power and b power, which is a combo of a power and b power, which we have already seen. All this is what we have already completed. So 256 by 8, if you do, what are we getting? So 256 by 8, if you do, you will be step off, that is what you consider. The integral part is what you consider, because number of terms is always considered as an integer. So 32 terms, even if you get 32 point something, you please take it to be 32 there. Right? Understood? So 8 3 is 24 and 1 6. So 32 is the exact number is what I have now. I need to check for this one also. So NC0, A is what? Root 3 to the power 256. Does that match or not? So 3 to the power 256 by 2. Yes, it's an integer. So another term also added there. So 32 plus 1 altogether 33 terms is what I have. Is that clear? So all these 33 are the integral terms. Understood that these are all integer terms. So this question is applicable for not only integral terms, but also if the question is regarding rational terms. Rational terms also you do it in the same way, even though it is rational. What do you mean by rational? Without that under root values, isn't it? So the question is applicable for even rational terms. Even for that, you can apply the same process. Understood? Now tell me, if the question is irrational, in the same question, if they are giving you, find out the number of irrational terms. How many altogether, how many terms are there? We have a total of, if the question is regarding irrational, I'm talking about number of irrational terms. If the question is, obviously take it to be total count to be 257, from which you remove that 33, isn't it? So that 33, if you remove, what do you get? That is same as 224. Understood? So 224 terms are your irrational terms, and rational terms are your 33. That's how you get it. Understood? Another question of the same type is what we'll be doing. Right. So for the question, the number of irrational terms in 8th root of 5 plus 6th root of 2 whole to the power 100. So now think about 8th root and 6th root. So this is 1 by 8 and this is 1 by 6. Yes. So LCM of 8 and 6. What is it? 8 and 6, right? 8 3 is 24. So 24 is the LCM. Now your 100, you divide it by 24. How much you get? Divided by 24, yeah, 4 point something is what you get. Step of that function is what you can consider. What is it? That is 4, you got it from here. right? Now you need to check for these extreme values also, right? So that is 4 you got. Now how about your 5 to the power 1 by 8 whole to the power 100? Is that also divisible or not? That is also you need. So if you observe the first one to the power 100, if you take 1 by 8 to the power 100, no, 100 is not divisible. So hence I cannot go with this. Even if you observe 2 power 1 by 6 whole to the power 100, that is also not divisible, isn't it? So that also you cannot take. So you just have 4 rational. 4 rational terms in the sense, how many irrational terms you will have? How many irrational? From the total number of terms. Total number of terms is not 100, darlings, please. Total number of terms is 101, right? So 101 minus 4, how much is it? So that is your 97. So how many terms do we have? So 97 should be the count. Yes, tally. So 97 are my irrational terms in such an expansion. Understood the problem? Right. Yes, now coming for the finding the greatest term between 101 to the power 50 and 100 to the power 59 plus 99 power 50. So now all this is one term and this is another term. Now the question is regarding which is greatest among these. In between these two, which is greatest? So generally, if you look at the question, people will think that yes, this has got 2 terms and this will be greater. So, but apply the logic there. And observation skills are very much needed. So you have 100, 99 and 101. So 101 we know that it can be written like 100 plus 1. 99 we know that it can be written like 100 minus 1. I am just going to apply this logic there. So I am trying to figure out what is 101 to the power 50, which is 100 plus 1 whole to the power 50. I can, and this is 99 to the power 50. I am treating it like 100 minus 1 whole to the power 50. Can I just take, 1 power 50? Yeah, 100 to the power 50 is what I can take common. I am left with 1 plus 1 by 100 whole to the power 50. Even here, 100 to the power 50 if I take common. 1 minus 1 by 100 whole to the power 50. Right. Now, what am I going to do with these? Think about it. When I'm adding, which are the terms getting cancelled? Or when I'm subtracting, which are the terms which are getting cancelled? Think about that and tell me. Do I have to add them both or subtract them? So how do you decide that? So first expansion, what are the terms in this first expansion? 50. So numerical coefficients is what I'm just considering. 50 C0, 50 C1, 50 C2, 50 C3. And all of them are in addition. Now coming for the other one. 1 minus 1 by 100 whole to the power 50. 50 C0, 50 C1, 50 C2. Okay. But they are all in subtraction. Clear? Right. So now what do I need here? Do I have to add them or subtract them? Think about it carefully and tell me now. So you need, we are talking about this and this 99 power 50 and 101 power 50. If at all it has to go back to the same position, we need to take a subtraction here. Understood? So that is the reason why we are subtracting. While I am subtracting, what do I have there? Yeah. Subtracting both the equations, what do I get? So I will be getting a 2 times something there, isn't it? So while I'm subtracting, obviously these both get cancelled. 2 times 50C1 plus 50C3 plus so on is what I get, right? So now think about it. So this is my 101 to the power 50 minus 99 to the power 50 is same as writing 50C0 and all these 100 to the power 50 is taken common, then 2 times something, isn't it? So now we definitely know that this is greater than 100 to the power 50. How can I say that? See, this is a complete value when multiplied by 2 into some big number is what I am getting that. So obviously this is strictly greater than This value is definitely greater than 100 power 50, isn't it? So now, is it same as writing? Just now you send it to the other side. 101 to the power 50 greater than 100 to the power 50 plus 99 to the power 50, right? So your first one is only greater. Understood? Yeah. So with this, we are closing the level 1 problem. So these are all the based on level 1. Yeah, let me give you one or two more problems there. Fine, just another problem is what we will go with. Right. Right. So ratio of seventh term from the beginning and ending of a 3 root cube root 2, sorry. Cube root 2 plus 1 by cube root 3 whole to the power n is 1 by 6. They have given find the value of n. Right. Tell me, suppose if I have some 10 terms, if I have some 10 terms, out of these 10 terms, or else let me go with a smaller number. Let me give you 5 terms only, right? So 1, 2, 3, 4, 5. Now tell me, what is second term from the ending? Without looking at the order, you have to tell me. So if you are telling me 5 minus 2, what is there, ma'am? 3, that is wrong, isn't it? 5 minus 2 is not the answer. It is not the subtraction of these two. From the end, if you are calculating 1 and 2, so that will become your fourth term. But your answer to me is 5 minus 2, that is 3. But plus 1 is what you need to take there. Understood? So that is 5 minus 2 out of 5 terms. If I'm asking second from the end, 5 minus 2 is not just sufficient. Plus 1 is what you have to consider there. Understood? Now if I want third term from the end, that is your 5 minus 3 plus 1 again, isn't it? So 5 minus 3 is 2, 2 plus 1, that's how you got 3. Now 1, 2, 3, 4, 5, 6, 7. I am giving you 7 terms. Now tell me, out of 7 terms, total are 7 terms. Now the term from end I want. That means suppose if I want third term from the end, what will you write? That is 7 minus 3 plus 1th term is what you need to write. Understood? Because 7 minus 3 is 4. 4 plus 1 is 5. Now let us calculate. I want third term from the end. 1, 2, 3. I got it, isn't it? Understood? So now tell me, total n terms are there. You want rth term from end. So is it nothing but n minus r plus 1th term or not? Right? Now based on this logic, now you tell me n is there. Now total number of terms how many? Total number of terms will be n plus 1. Out of these n plus 1 terms, I want 7th term from the beginning and 7th term from the ending. 7th term from the beginning is T7, which is R equal to 6. You consider there. And 7th term from the ending is what I have a problem now. I have total of n plus 1 terms. Now I am going to subtract minus 7, add by 1. Is that clear? So finally, which is n minus 7 plus 2, which is n minus 5th term. Clear? So n minus 5th term is what my term from ending. Right. So, yeah, so Tn minus 5 will be my term from the ending. Now, obviously, this has to be written like what? R is what? How much? What is R equal to from here? N minus 6. 1 less than C. If it is your T5, fifth term in the sense, what do you write? T5, do you take R equal to 4? Because 5 plus 1. No, 4 plus 1 is 5, isn't it? Clear? If it is T6, 5 plus 1. So R is 5. Just one less than that is your R. Clear? Whatever number you write, T10 you write, R is 9. Just one less than that. T100 you write, R is 99. Just one less than that. Clear? So in the same way, what is R here? You have your T, n plus fifth term. Hence your R is just one less than that. That is n minus 5 minus 1 again. So R is your n minus 6. So what is your term there? Now n c n minus 6. 2 power 1 by 3 whole to the power n minus 6 into 1 by 3 to the power root 3 whole to the power n minus 6. That is ratio of the term from the end. The term from the end. Now, what is the term from the beginning? Seventh term from the beginning is T7, which is R equal to 6. So, NC6. Now, 2 to the power 1 by 3 whole to the power n minus 6 into 1 by cube root of 3, or else you can write it to be the same thing. Okay, fine, whole to the power 6. Now, when I substitute the formula in the ratio is what I am just going to do. Right, now ratio of this to this is what I'm going to write now. Right, so let us write it carefully. NC6, 2 to the power n minus 6 by 3 into 1 by 3 to the power 6 by 3. Is that clear? Because 3 to the power 1 by 3, again whole to the power 6. Is that the question? 3 power 1 by 3 only? Right, is 2. Now coming for what is the rth term, seventh term from the ending is what I have there. So that is NC n minus 6, 2 to the power n minus n minus n plus 6, n minus of minus n, isn't it? N minus r. So n minus 6 by 3 into 1 by cube root of 3. In the sense 3 to the power n minus 6 by 3. Right. Now, observe here carefully. What is NC n minus 6? Is it same as writing NC subtraction of these two? N minus 6. Ante n minus n plus 6. Clear? So, obviously, these both getting cancelled there. Right. Now, observe carefully. I am left with 2 power n minus 6 by 3 by 3 to the power 2 is 2. 2 to the power, these both got cancelled. 2 by 3 to the power n minus 6 by 3. Now I am just taking a cross multiplication for the ratio. What is it? So 2 to the power same with 3 to the power same number, which means that is 6 to the power n minus 6 by 3 is 2. Again, 3 square into 2 square, 6 square. Right. Now they said 6 to the power n minus 6 by 3 by 6 square is same as 1 by 6 is what they are giving as a condition there, isn't it? So ratio of these two is same as 1 by 6. Now from here, 6 to the power n minus 6 by 3 minus 2, a power m by a power n minus n equal to 6 to the power 1 by minus 1, isn't it? 1 by 6 is 6 to the power minus 1 there. Now take their LCM and equate your powers, that's it. So n minus 6 by 3 is your minus 1. So n equal to how much? This is minus 3 plus 12, n equal to 9 is what your answer is. Understand? So ratio of seventh term from the beginning to the ending will be your, so if the ratio is given to be 1 by 6, your answer for n to be your 9. Right? So here ends the session 2, which are the problems relating to number of terms, consecutive terms, all these concepts are done. So next coming up video will be based on the sum of the series NC0 plus NC1 plus NC2. How do you get C0 plus C2 plus C4 plus C6? All these terms is what we are going to discuss in the next video. So keep watching. Bye-bye.